Okay, here we go. All right, where are we at? We did cells. We talked about the publish tool. We talked about error codes. And that was it, right? That's where we left off. Is that correct? Today I'm going to have you do some coding yourself a little, make it a little more interactive, but a couple little things I have to talk about. Some other basics. MTS, how's it going? I just got an email from you at MTS about 2 seconds ago. Yeah, clear as so. Okay, basics. There are different data types that are built into MATLAB. Most part, what you're going to do is just numeric data types, right? So it's just like, if you have a variable set up, is it a string? Is it a date? Is it a time? Is it a table? Is it a structure? Is it a cell? Like, those are the data types that we're talking about. For the most part, what we're going to do in this class is just strictly numeric, at least starting out. So those are just be wary. And if sometimes you'll see a string, so you'll deal with strings sometimes too. If you want to label like a plot, like the axes in the plot, the command you give it, you have to say, I'm going to give you text, and it's not a number and it's not a variable. That's called a string. And what we do is just put little single quotes on the outside of it. You'll get some experience with it, but you put little single quotes on the outside saying this isn't a number, this isn't a variable. It's what it is. It is what I gave you, and then it'll label the axes and stuff accordingly. For the most part, that's what we're going to do. So basic operations, like what can MATLAB do? Well, MATLAB has it could act as just a calculator if you want. You could see just some code that I put directly into the command window, 2 plus 2. Obviously, it knows what plus is, it knows what minus is, it knows what times is, it knows what dividing, it knows taking it to a power by going with the little caret function, right? And then it has the orders of operation built in. Like, so if I plugged this in to, oh, what the fuck? When was somebody going to tell me that it's not being displayed? Thank you. I want you to guess at what I'm pointing at. I want you to guess. Also, I keep looking over there. And I was like, what is it? Okay. So, like, if I was to plug this in, if I plugged this in to MATLAB, it knows the basic orders of operation, right? It'll go, oh, I'm going to square this thing first. I'm going to carry out that thing inside the parentheses first. I'm going to, and then I'm going to add it to 5, and then I'm going to multiply it by the number that's already been squared. It's built into it. So as long as you put it in there. That being said, many errors you're going to have is that you put it in incorrectly. Even though it does our orders of operation, correctly, you have to make sure that you set it up to do the orders of operation correctly. You have to put the parentheses where they need to be. You have to be a little careful about that. And a lot of errors come from that. Okay. They also have a lot of other built-in functions. Square root, right? Square root, cosine, sine, pi, etc. Like all those things. And here's a list of all these like built-in functions that you can use. And there's just obviously way more than I can ever just lecture at you. Right? But then again, if you're curious about it and you're trying to use it in your calculations, go to the help, and the help tells you how to use it and things like that, because they all get used slightly differently. Okay. And then you don't want to do these things, we said before, directly into the command window. You want to use script files, which we talked about last time, .m or .mlx, either one. Right? A lot of times the .mlx is a little bit easier when you're doing basic stuff. Okay. Creating using variables, right? Obviously, that's something we're going to use a lot, is you're going to create a variable and use it. In some programming languages, like if you're using C++ or Fortran or something like that, you have to initialize a variable first. You have to say, hey, I'm going to have a new variable. It's going to be R, and it is going to be a number. And you have to tell it that. So if you program in C++, you have to do that, right? What's really nice about MATLAB and why I like to teach coding with that is you don't have to. It's super loose. You just say R equals 10. And then since you set it equal to a number, it knows, oh, R is going to be a number from now on, right? So then I say R equals 10. So from here on out, R, every time I type R, it'll replace and put 10 in that place, right? So then I come down to the next line right here and I say D is equal to 2 times R. Well, it just goes 2 times R, which R is just 10, and it's just 2 times 10 is 20. I did that in my head, okay? And then the answer to D would be 20. And then the area would be pi times R squared, and then that would calculate that. And pi is it's a built-in variable, so it knows that's 3.14159. Okay, and then it squares there. Okay, and then just be really careful. Oh yeah, and we mentioned this before. If you put semicolons after it, it hides the output. So sometimes you may want to do that. Put those semicolons. Usually I actually put semicolons around behind everything. It just keeps your code a lot cleaner, unless you really want it displayed. Like if I really want to display what the area was, I don't put the semicolon afterwards, and that'll be some of the output. It just keeps it a little bit cleaner if you put semicolons after everything. Just be careful of your naming rules. You You just have to be careful, right? You can't start with a number, I don't think. Must begin with a letter. Names can include any combination of letters and numbers and underscores. Maximum length of variables is 63. Please don't ever get into a coding where you use 63. Actually, do. That'd be pretty funny, where you have a variable that's 63 characters long. It is case sensitive, right? Capital A is different than lowercase a. Avoid the followings: aj or ij, pi, length, char, size, right? Because those are built-in functions. It'll let you do it. I could make a new one called length equals 10, and then from there on, length will be equal to 10. But there's also a command called length, and then it'll get confused if I ever try to use the command called length. So just be careful of that. Practice is name your variables to reflect their function in a program rather than using generic X, Y, Z, which I absolutely agree. Call it out what it is, right? To some extent. I don't have 63 characters to describe what the variable means, but try to spell it out. Okay, I'm gonna have you do this right now, okay? Get out your MATLAB, get it ready to go. I'm gonna have you create a MATLAB script, stored in your desired folder. Again, I use my MATLAB drive, and in MATLAB drive, I created a subfolder being like class examples, and you could do the same thing, okay? Name it lecture 1 example.mlx, meaning that it's gonna be a script file, okay? And then also you gotta be really careful. You don't ever put spaces in there. It can't handle spaces in the file name. So make sure you don't ever put any space in there, okay? In this folder, in this file, I should say, create a cell labeled basic math and perform some of the basic math calculations. Now create a cell called, remember creating cells when you put that double parentheses and it breaks it into different cells that you can run. And then define some variables, and then the last step, create that thing that calculates that. Okay? And I'm gonna say, go, do it. And then if you have any questions, let me know. On the side right now, I'm gonna do it myself. I'll race you. Right. Ooh, I'm already off the lead. Save this as lecture 1 example. Five plus 5. Done. Whew. Huh? Davidja?
Yes.
Damn right. Unmatched skills. Unmatched skills with it, MTS. Is everybody getting started? You kind of know? Do you need some assistance? I'm walking around. You did it. Yeah. Did I beat you or did you beat me? Just that close. Oh yeah, hell yeah. Hell yeah. You broke the cells by doing the 2 parentheses and then a space, and then it breaks it into a cell.
2 parentheses and a space.
Yeah, percent sign, sorry. 2% signs, then a space, and then you label it. And then it automatically will do this, like you did that.
I don't think I needed a.
What did you need there?
I don't know. I'm on my way.
Yeah, you did it. Yeah, how did you break it into cells?
I think I just did like. Nope, I did have a space.
2%. Yep, there you go. Yep.
Wait, how do I undo that? Oh, just
Yeah, just delete it. Yep.
A very quick question. So
Yes, Joseph.
for the making it into like code, why would it be grayed out? Actually?
Oh, it's something different.
Okay.
We're not. That compiles it and turns it into like a program.
Okay.
So like you like Excel, and then you could give somebody that, and then they could run it, and that's compiling your code. We do not do that.
Okay.
Yep.
So making the basic math like section, like how you
Yep.
have an area calc, like a title.
Yep.
What is the code to start that?
Percent
Percent.
space.
Space.
Yep. And then what do you want to call it? Basic math or something like that.
Space. Okay.
This is the one.
Do you have a question for me?
Gotcha. Okay. Thank you.
So how come mine are off to the side?
Yep, you can change how you want it. So these little buttons off to the side, it'll let you do it different ways.
I just prefer.
Yeah,
this way.
sometimes it's nice off to the right, but then when I'm lecturing, sometimes I like it down below because then you can see like I put the code and there's the output directly below it versus off to the side. So, yep. Did you get it there, MTS? This is easy stuff for you, dude, right? Easy. How's the writing coming?
It's been good.
Good. Good. I haven't looked at it forever. I think Chris probably hasn't looked at it in a while because they're. Yeah. Cool. And then I won't look at it for years. Years and years, MTS. Years. Did you get it there, Kyle?
Yep.
Did you copy Sean's?
No, actually.
Oh, hell yeah. Did you get it?
Oh, yeah.
Yeah, okay, good. Good. Everybody over here? We doing okay over here? Elliot? Ethan? No?
You are him.
Oh, you get rid of the percent sign. Or sorry, the semicolon. The semicolon says don't show it. And so if you ever want to show like area of the perimeter, just get rid of the percent or the semicolon and now it's
Yeah.
Yeah. But yeah, if you have semicolons after everyone, then it won't go.
It's inefficient.
Which is something you want, right? Especially if you're doing it for what's that?
You did 2 times L plus 2 times W. You could have done 2 times L plus W.
Oh yeah, I could have done that.
You should have done it.
I should. That's how my brain works. My brain works like that. You get it there? You get it, Noah?
Does yours have the thing where it does like area underneath? Zach, can you show me how to do it?
What did I do?
Is it
Oh,
similar?
under that?
Oh, it is fully away.
Yeah, because mine will come up on the
Mine
side.
comes on the side. Wait, I think
Yeah, just right click. Over an empty spot, you right click and then new. And then you got folder or script or whatever.
I have a question.
New.
Season.
Folder.
Sorry.
Yep. Yep, and then you can drag it all in there. And then I think somewhere you can, wherever this current folder is, in wherever it's at in your thing, it's just a folder. So you can go in there and move stuff around if you want to. You know, you can open up and it's in there.
No, this is
You can open up in what's it
It's just
called?
like a layout thing.
Explorer, whatever, file Explorer. You can open it up there too.
Oh,
But sometimes it's, you
I
can
know.
just, you can drag it
I know
around
what it
in
is.
there, just like one. Yeah.
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 So you know how it's these side things. and
Yeah,
the
yeah,
layouts,
yeah,
and like the
yeah, yeah,
second
yeah,
one,
yeah.
that's where
Yeah, so it gets a little organization to it. Yeah, damn right. What did you need?
I figured it out.
Yeah, yeah, the thing on the side. And you can change how you want it to the side, you want it below it, whatever, right?
Yeah, these things on the side. So variables until it's the second one. And so that's what you have to do.
I kind of like it over to the right, but when I'm lecturing, I like it just like below it, just so you can like see it.
That is kind of nice. I don't know.
It definitely is better than doing a .m. The .m file, you would never see anything in this script. It'd all show up down below, like where that blinking cursor is.
Wait, can you show it live?
Yeah.
I mean, it's mainly just for you. So
That's like, I
whatever.
never.
Yeah. If other people look at it, it's like, whether you want it.
It's actually strange that he's on it right now. You guys got that?
Okay, so if you want to see this, I made a .m file so you can see what it does. So there's a .m, not a .mlx. It looks the same, but if you ever go to, whenever you go to run it, right, nothing shows up here. All the calcs show up down in the command window, down in here, right? And so it's just, that's how it used to be. Like with the original MATLAB, that's what they did, and it's just not very conducive to demonstrating these simple problems that we do. But again, sometimes later on, we're gonna do this one a little bit later where we do this calculate. There's this little algorithm. If you run it over and over, it'll make this like cool triangle, and we'll do like millions and millions of calculations. You won't do that in a .mlx file. You do that with a .m. It just runs a lot faster and smoother in a .m. But for these like little example stuff, the .mlx is way better. There we go. Yeah, there you go, Melissa. Isn't that funny?
I'm gonna start wearing a name tag to this class.
Maybe you should. Okay, so that's everybody good there? Everybody questions? We're all good? We're squared away. Let's talk about matrices, right? Little FYI, MATLAB is short for Matrix Laboratory. Huh? What a good time, right? That's what its strengths is Matrix Laboratory, right? It is really, really, really good at handling matrices, right? And if you're ever going to do anything exciting, we're going to do it with matrices. So we'll just kind of go through how do you define matrices in MATLAB, right? Well, there's a couple different ways that I'm showing right here. Here's a little way, right? We'll do an example. We'll do another little exercise in a minute, but I usually do it this way right here. That's what I do. This is the first row, then I put a semicolon. There's the second row, then I put a semicolon. There's the third row, and then I close. It's a square brackets. You have to use square brackets, okay? And then that's all I do with that. It'll accept that. I could also put commas in between each of the rows or each of the columns in a row. I could do 1, 2, 3, and then the semicolon says now I'm going to a new row, 4, 5, 6, new row. That works as well. Okay. You could also do it this way. This is more aesthetically pleasing. Okay. Then you do a row, and a row, just like that. It'll take that as if they had semicolons. They all give you the exact same result. Again, I always do this one. This is when you're coding stuff out. It's a little bit nicer up here to do that one. Okay. And then you can make it any size as well, right? And then if you do 5 times A times B, it performs matrix multiplication. If you just put a times there, it'll automatically think that you're doing matrix multiplication, right? The problem, we'll deal with this stuff later, that sometimes you don't want it to do matrix multiplication. Sometimes you want to just do element by element multiplication. So it does 1, 1 times 1, 1, 2, 2 times 2, 2, 3, 3 times 3, 3, right? Sometimes you want that, but usually we're going to want to do matrix math. But again, matrix math has to be right? It's the boop, 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 boop. You know, remember that? So it'll do that for you. Okay, it has built-in commands, inverse, okay? INV of A will take the inverse of a matrix, okay? If I take the inverse of matrix and multiply it by the matrix, it should give you the identity matrix. That's the reason why we do the inverse, is it just basically, it's like dividing by A, okay? There's a command called size that returns the size of the matrix, which is the rows and columns. It'll return to you the number of rows and the number of columns that you have, because sometimes you might have this really big matrix and you want to know how big it is, you just say size of A, okay? Determinant of A, right? This little prime here takes the transpose of a matrix, which is just flips it up on its side. Sometimes you want to do transposes like we did in structural dynamics. We use the transpose of stuff. You just they also have a command called transpose, but the shortcut is just to put a prime on it. Right? You can't do, it'll give you an error if you try to do if your inner matrix dimensions don't agree. You got to do a 3 by 1 by 1 by 3. You can't do a 3 by 1 by 3 by 1 because the inner matrix dimensions don't agree. That's a big error that a lot of you'll run into. Be careful of that. This is also a big thing, is indexing a matrix. Indexing a matrix is you're just plucking elements out of it. So what if I said A1 comma 3, it says, right, in the A matrix, give me the first row, third column. Right? It goes rows and columns. And it will return to you what that element is. Right? So if I want to say, well, sometimes you want to do it. Sometimes you want to pluck little elements out. And that's what you do. A1 comma 3 would return to you that value. You can also shove something else in there. I could say A1 comma 3 is equal to 12. It takes whatever was there, deletes what was there, and puts a 12 in its place. I think over to the right here, it has all those. It has what happened there. I don't know where those are at. I don't know, somewhere the output is. Again, you're going to do an example here in a second, okay? This does matrix math when you put the times there. The dot times does element by element. So it goes A11 times B11, A22 times B22, and so forth. It just lines up those elements and does matrix math. Sometimes you want to do this. Sometimes you want to do that matrix math, okay? There's some special matrix commands. A 1s, 2, 2 just gives you a whole bunch of 1s, as the name implies. Zeros, what do you think zeros gives you? Zeros, right? And then it'll give you how many rows and columns. So then zeros 3 comma 2 gives you a 3 by 2 matrix of a bunch of zeros. And then EYE4 gives you a 4 by 4 identity matrix, which I think is very clever of them, right? To make the command I, giving you the I command, right? Isn't that clever?
I think so.
Very clever. Okay, and again, you'll do this. And then like some examples, like when in structures 1, when we make like the stiffness matrix, or in finite elements, when you get into that, you make a stiffness matrix. A lot of times, most of the elements are zeros. So you want to start out and just populate it with a bunch of zeros, and then throw in the other components, and then you don't have to go back and fill in everything else with zeros. So there's all sorts of reasons why you would do that. Okay, there's other things. Sometimes you may want to make these vectors of various sizes, and this is what they call the range operator. This is something we're going to do a lot of, is a range operator. If I wanted x to be a vector that goes from 1 to 10, this is what I do. X equals 1, and then the range operator is the colon. If I put a colon in between there, a 1 colon 10, it creates a vector of 1 through 10 with a space of 1. Right? So it would get, but the answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And I don't know if I put the output. No, I don't have the output over there. Right? And so it returned that. If I do it like this, the range operator, going from 1 to 10, and I put a 0.5 in there, what it does is it gives me a vector going from 1 to 10, but a half increment. So it'll be 1, 1.5, 2, 2.5, 3, 3.5, and so on. And you can put any number you want in there. Right? And so when we're doing plots a little bit later, and you're going to have x going from 0 to 10, and we're plotting y, where y is like x squared, for instance, we're going to be using these, because everything has to be a number in MATLAB. And so this is how we're going to define those. We're going to define x's with the range operator, and then y is going to be some mathematical calculation based off of that x. And then, and sometimes you want different spaces, like it's a little tighter. Anyways, we'll get to that a little bit later. But that's the range operator. So you can see that. That's a way of making matrices really fast. Okay, or vectors really fast. All right, here's the exercise. Given the following matrices, A and B, calculate the product of A times B and store it in C. Transpose A and store the new result in matrix D. Calculate the determinant of B and store that result in X. Use the built-in function inverse to find the inverse of A and store that result in E. Use the built-in function EIG to determine the eigenvalues and eigenvectors. And then use matrix A, B, C, D, X, Y, and Z to do this new thing where we're going to pluck out those different components. Okay? What does this do? Nothing. It's just playing around with stuff, just to try it out. I'm just going to leave now. Good luck. Yeah. Joseph.
What is the...
You create this new file, you just do it in the same file you already had, it'd be fine too, right? Yes.
What is the built-in function of I, and how do we utilize that to...
I wonder if there's a place to look at that. In the help. It'd be in the help. It'd be good exercise to go to the help. Go to help
Get
chapter.
to the help again.
The help.
Also, what's going on with the inverse?
Warning, matrix is close to a
How do you
singular.
do it for,
They just do a warning.
to make it two different ones?
It's just not a well-formed matrix.
But like this
Oh, look
is
at you, been working ahead.
yeah.
Good. Yeah.
Well, how do you get to the help again?
Just there's a little.
Oh, question.
Yeah, question mark. And then what's it?
But this, how come like, cause you did the inverse of A here.
No, I just did the.
You got.
It just depends on the matrix.
Isn't the same matrix?
Is it the same matrix?
Well,
They might not be lined up. That could be something because it is a product. It is.
It is the same matrix.
You see, it may have been giving me a warning.
Oh,
there.
you have a, no, it's not. You have
Okay.
a 10.
Yeah, probably because it was giving me that
Oh
error.
my
Probably because it was giving me that error. And so you may get a warning on it because it's a property of the function. It's just a singular matrix, which means that it yeah make it a 10. See, but that should go away.
It does.
Yeah.
Ooh, but I don't get the same answer. But it goes away.
Yeah, you should get the same answer. Yeah.
Wait, how does
And
the
then-
warning go away?
Hmm?
How
What's
does
it
the warning
say? It
go?
is a singular matrix. It's going to give you a warning. That's okay. It's just a warning. Yeah, it's just a warning.
Just a
It's just a warning. It's just an ill-formed matrix. Because I just made it up. You notice the pattern? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it'd be good to open up the help thing because the way you use I is interesting, and they'll show you how to use it.
Should it be obvious how we use
Just
the
right.
Can we just like search here?
There might be another way to do it too. Let me see. You know what you could also do? I don't recommend it. It's not pretty. But, Kayla, if you, down in the command window, if you type help, space, and the command that you want to use, it gives you this. So I just wrote help eig, and it says eig, eigenvalues and eigenvectors. This MATLAB function returns a column vector. This is how it works, right? It's just not as pretty as doing it in the help.
Yeah.
But that's like a quicker way to get there. The other thing I did, Kayla, I just up here in that little window over the top, you could type, or back in MATLAB. That's probably worse better. Just type. See my little window up there next to the editor? Over here. And then type in eig right there, and it'll take you right to it. And then click on eig down there.
Is it? What's
Hmm?
is this? I'm gonna do this one, but what's the symbology?
Oh, we'll get into that later. Right now, everything has to be numbers, but then later on, we'll use a symbolic
squares
toolbox.
and-
Well, like it'll handle it as an undefined. Like you just say x is x. You know, x is a variable x instead of x is equal to 10 or something like that. You say x. If you just type x right now without it being a symbol, it'll say I don't know what x is. But then when you define it as being a symbol, it'll treat it as if it's a variable x. And then when you do anything to it, it'll do calculations on it as if it was a variable.
Oh, cool.
And so then, but that's a little bit later. Yeah. We're gonna just use it as like this first. Let me just show you help really quick. Eig is something I asked you to do. One easy way to do it, up here, there's this little window up here, this little guy, right? If you type in any command, like, oh, I wonder how to use eig, you type eig into that, and it takes you to the help right to eig. And it gives you a couple different options here. We're not gonna use the symbolic one. I wanna use this eig. If you bring it up, it's really nice because it tells you how you use it, right? E is eig of A and returns the eigenvalues. I could do it this way. V and D is equal to eig of A, right? And then there's different ways. You look down here and it'll tell you what each one's. If I say, it's interesting, that's a little confusing with MATLAB. Depending on how you use it, it'll return different things. If I just say E is equal to eig A, it returns column vectors containing the eigenvalues of a square matrix, is all it does. But if I out front and say in braces V comma D is equal to eig times A, it'll actually return to you two things instead of just one thing. Because you have two things to catch it, it'll recognize, say, hey, it's trying to catch two things instead of one thing. And if you do it that way, it returns a diagonal matrix of eigenvalues and a matrix whose columns are corresponding right eigenvectors. Right, so it returns to you both of them, but you have to ask for both of them, and it'll return both of it. But if you only ask for one of them, it's only going to give you the values. So a lot of things in MATLAB work this way. And then how do you figure out how to use it? Well, under this help, it tells you all step by step on how to do it. Sometimes you could even give it extra parameters, right? Or there's this thing called a balance option or an algorithm or output form. And if you scroll down, right, there's actually executable code that you could run, and it demonstrates how they all work. Right? Like right here, it's like, oh look, if I make that equal to this, if I make that equal to this, if I do it this way, I get this. If I do it this way, I get this. Right? And it shows you all that stuff in the help. It's super helpful. Right? The help is helpful. Did you get it?
I believe so.
Yeah, sure. Yeah.
What?
Yep. On it, dude.
I just don't know if this is right.
I don't know if it's right either. It doesn't matter. Yeah. Doesn't matter as long as as long as you're confident in what you're doing.
Okay.
Yeah.
Can
Yeah. Do you want me to do it really quick? And I can get
No, I was
yeah.
actually just wondering if you could check and see if this looks
Sure.
semi maybe right.
Yeah.
Semi what?
Semi maybe right. The F part.
Store it in X,
Oh, yeah, you
Y,
can do it like that. You mean the other thing you could do is like, so you took. Where's the thing? What did I say? Where's that thing?
It's number 6. Yeah, number 6.
Oh yeah. F11 is equal to X. Yep. And so in the first part of 1, 1
Yeah.
of the matrix is going to be X, and the X you defined up amongst the place, right? So then,
Yeah.
Yep. And the F12 is Y of 1. Yep. And so then it goes to Y, and then Y is a bunch of stuff, and it finds the first element in Y, and it puts it in 1, 2. Yep.
Okay.
And then F21 is Z11. Yep.
So C and Y.
Yep.
was
Yep.
the
Yep.
same. How are they different eigenvalues? You want to use the D and V?
Yeah, one of those ones.
D and V, but they equal X and Y.
Yeah,
Yes.
I'm a
Yeah,
little-
you can label it whatever. You don't have to call it V and D. You can call it X and Y, but just
So the
V is
E-
gonna be one thing, D is gonna be the other.
Those are arbitrary variables.
Arbitrary variables.
So
You
the
just have to
E-
say yes.
Okay.
You say I'm gonna catch it, and I'm gonna call. I mean, better would be to call it eigenvalues and vectors or whatever, right? Whatever they actually are. 'Cause that's a better
So
variable
for
form.
the values, we would say y equals I.
Yep. Yep.
I'm just curious as who's
Yes. Unless if it's all you're catching is the values, then yes. But if you're catching the values and the vectors, then you have to put in two things. You have to ask it to catch two things, V and D. One of them's the values, one is the vectors. So what did I ask to do? I said.
So results variables Y and Z respectively eigenvalues and eigenvectors.
Yeah. So then that one, Kayla, you would.
So,
Got it.
So we go back to this help. I'll show you.
so I would be doing y comma x.
Yes.
I comma
Yep.
y.
Exactly. Yep. Because it,
I wish this was a touchscreen.
I know you just
I'm like-
rubbing your fingers all over it. Yeah. Because see, if you ask, you have to ask for both. V comma D, and then you'll catch X and Y or Y next or whatever I said. And then you get to you don't have to label it V and D, but that's what it returns to you, and you'll catch it into your own variables.
I went swimming this morning.
Where?
MTS.
Really? Is it nice?
I'm really bad at swimming.
Oh. It's an ill form. It's a bad matrix. Because I just made it up. 1, 2, 3, 4, 5, 6, 7, 8, 9.
I'm like,
Yes.
Yeah, no, do you want to go over this split? And I was like, oh, people catch me 40 times over. So bad at swimming. People are so good at swimming. People are so good at swimming. Like, I was swimming this morning.
You did?
I did. I was like, oh, I want to get back into swimming. I've never really been a swimmer. I want to get into swimming.
What terrible sport.
It's exhausting.
Yeah. And you
I
just
did-
stare
I
at the
did-
bottom of the
I did
pool for
4
hours.
laps, and then I stopped and I stood up, and I can feel my heartbeat in every part of my body.
But it's
I felt like I was
so
gonna
fun.
explode.
It's not fun.
I felt like I was gonna
Yeah,
like
it's
fall.
You just stare at the bottom of the pool for hours.
Yeah, but you're in the
Hours,
water.
bro.
Like you're just paddling around.
Yeah.
It's fun.
You're not, you're like, and then your heart
No, we're talking
feels like
over here.
literally a battering ram against your chest, and you can't breathe. Because like when I run, I can breathe however much
Funny
I want,
story, Mike.
But you can only breathe when your head is out of water, or you just like choke a little bit, which I did.
My mother-in-law.
Bro,
We went snorkel.
That's a
the only guy.
Exactly.
An adult.
So you can breathe while you're swimming, dude.
Exactly. You can do the backstroke.
I went to a gym once with my mother-in-law, and she was swimming, and there was like a kid section, and she was swimming around in circles in the kid section. I'm like, "What are you doing, Beth?" Because she was scared of the deep end. Because when she right out the deep end, and she looked out, and it just scared her, and so she stayed. She literally did loops around.
That's so funny.
It was fun.
Okay.
Oh my god.
When I'm doing 6, do I literally just put F11 equals X, or do I need to do something?
No, F11 is X. And so then what it'll do is it'll make a matrix, and in 1, 1, first row, first column, it'll put what X was.
Is this like one line across, or do I do like
It's separate
this?
lines.
Return
Yep,
this?
yep, that return, that
I
return.
don't need to like
That'd be the
label
product I did.
F
I'm so
at all
silly.
first.
Nope.
Give it.
That's what's really nice. In MATLAB, you don't have to initialize anything. And if you start making your matrix bigger, it'll just grow. It'll just keep growing and making it so that there's room for it when you do that.
Okay.
You don't have to initialize any variables. You don't have to say what size they are. Nothing. You can be real loose with it.
So loose.
You guys have a question? You guys get it all? You did it? Yeah. I don't know what the answer is. Alright, I mean, it's all- Yeah, one of the matrices you can't be the inverse of it. I just made up the matrix and it doesn't have like it doesn't it's singular. That's why. Yeah. Yes, so the values are down the, so when it's giving you, the values are down the diagonal, and this is the vector for the coordinates, vector for the cycles. All that stuff you learn in math.
Yeah, actually, you know who reminded me of that one?
Right, because MATLAB or math has
That's
like
like the last
values.
one. Actually, no, the last one is pretty.
You subtract like lambda off the diagonals, and then you did something to it. You took the determinant of that.
Exactly.
Find lambda, that gave you values. You just bring it down, right? And you sometimes you can put it back in. And your memories come out. This is
Like
math.
went from the entire opposite side of the classroom.
Did you get it there, Don?
Towards me.
Okay. Everybody good? Connor, you got this?
Yes, we can be in the group.
Ciara, you got it?
Yes.
Everybody good?
He was judging us.
Did you get it there?
How to make mustard
What's your
gas.
name again? It was
Hudson.
He's like, I don't know how to make mustard gas. I
Yeah,
literally
Paul
was
was
Got
like,
it?
into that.
yeah, Paul was like really uncomfortable
Yeah.
too.
It was
Okay,
actually
cool.
so wild because he was just like, you don't know how to
So then I will have a homework for you by tomorrow morning sometime. We'll make it due next Friday is what it'll be, and I'm just gonna be doing this, just keeping going with this. Again, highly recommend you actually do it and don't just put it into ChatGPT. ChatGPT will kill it, and it'll do it. But again, we're gonna get to a certain point where ChatGPT is gonna break down a little bit, and you better know how to do the programming yourself. Also, another thing that I'm gonna have you do as part of your homework is I got an article. I saw an article from the New York Times that was, this is the end of computer programming as we know it, and we feel fine. And I've never read it, but I'm gonna have you guys read it. I'm gonna have you read it. It seems so. I'd like to see what it says. It'll be a reading it. We'll get philosophical, if you will. It's the end of computer programming as we know it, and I feel fine. And you may feel fine too. Because it is part of this class is going to be using it, just to help you out. But it does mess up, right? It does mess up. And then you got to be able to correct it in some capacity. All right. Yeah, guys, honestly, I should. Could you summarize this for me? I don't want to read it. It's too long. I don't want to read it. It's too long. My God, it is. If you don't use it on a regular basis, you really should. You really should. You really should know. You really should. You should. I use it all the time. You want a letter of recommendation from me? It ain't coming from me. ChatGPT is gonna go.
Yesterday, my dad and I were talking about how useful it is. He's like, I'm using it to compile like a maintenance log for the vehicles that we have.
He was doing it.
Yeah.
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 Damn right. Super useful. Like I just for Structures 1, if you recall, I had a plot of number of pages that ASC 716 has had over its history, and I just said, give me a plot of it, and then it gave me the plot, and then you can't trust it. So I went and looked up a couple of values, and it was real. It's like, where the fuck did it even get all that information? It is phenomenal. Another perfect place that I found for its use was we needed a letter of support from Montana Contractors Association, and we write the letter for them and they sign it. Well, it's not even my voice to begin with. It's their voice that I'm making up. I was like, I got this, let me do it, Kirsten. It was like one of the, I took care of that. I took care of that. I just said, write a letter from Montana Contractors Association that supports this thing, gave it the proposal, and then it just dialed, just beautiful. Just, oh, thank you. Okay, I already talked about this. This is the range operators. You can see it, what it would do now. You can see the output. 1:10 will give you, it makes a vector. It makes a vector. And it is a 1 row by 10 column long, and it just has a space in between them. And if I do 1.510, then it gives me another vector going from, starting out with 1, and it goes every half. So 1, 1.5, 2. And we'll do this a lot where if you're trying to do a plot of something where x goes from 0 to 5, you don't want it really choppy. You want it real smooth. And so you put a number there like 0.01 or something like that. And it immediately makes, 1,000 elements, and then you do all sorts of calculations with it. But you'll have lots of time to do that. Another way that you can make a big vector is this command called linspace. I never use it, but you know who likes to use it? ChatGPT loves linspace, right? Loves linspace. And so linspace, you give it the 0 to 10 and puts a space and 20 elements, I think is how it works. You give the range, it goes from 0 to 10 and has 20 elements in it. And so then it'll automatically linear space, right? It'll break it up into exactly that many spaces. So again, I don't ever use it, but ChatGPT uses it a lot, right? You could also put log space, so a logarithmic spacing in between them. And then again, a command, just like size, if you're dealing with vectors, sometimes you want to get length. It'll just return to you a scalar, how long it is, right? So length of x in this case ends up being 10. That's something we use quite a bit, okay? Simple math calculations. Okay, so then with vectors, this is talking about with vectors. This is kind of your first little more exciting stuff. So what I'm going to do here is I'm going to make, say if I want to plot x squared, right, or want to calculate x squared. First, again, everything in MATLAB, you have to define first. I can't just dive in and say, x squared. If I just did that without defining x, it would come back and say, I don't know what x is. Right? I don't know what's going on. Later on, we'll do a symbolic toolbox, and you can use it as a variable and just leave it as x, but I have to give it a number. So I'm going to say x is going from 0 to 10 with a spacing of 0.1, and then I'm going to do a calculation on it. I'm going to say y is equal to x squared. In this case, y1 is equal to x squared. If I just went in, right, x is a 1 by 101. If I just went in and I didn't put that dot right there and said run it, I'm going to just do it. How about equal 1 to 0.1? Just show you here, right? And automatically, it'll make my x. I put a, this is a dot. Sorry. I wanted to put this in a .mlx file. That was a .m file. I want to put it here. Right, and so it makes a vector 1, 1.1, 1.2, 1.3, so it puts spacing of 0.1. And if I come in and I say y1 is equal to x to the second, it's going to give me a warning. Actually, it won't even give me a warning. It just didn't work, right? Doesn't work. So the problem there is x is a, I mean, we can ask for the size of it. Just to show you how the size command works. It's a 1 by 91, right? And so it's a 1 by 91. And if I go x squared, it tries to do matrix math. It tries to do matrix math from the beginning. So it goes a 1 by 191 multiplied by a 1 by 191. Can't do it, right? Because the inner matrix dimensions must agree. They have to be the same. Can I do a 1 by 91 by a 91 by 1? Yes, because the two inner matrix. Do you know what I'm talking about? Inner matrix dimensions, right? The inner matrix dimensions have to agree. And it tells you error using the caret. Incorrect dimensions for raising a matrix to a power. Check that your matrix is square or the power is a scalar, the operation, blah, blah, blah. It's giving you a warning about that, right? I think you maybe get a different warning if I do x times x. Incorrect dimensions of matrix multiplication. Check that the number of columns in the first matrix matches the number of rows in the second matrix. So it even tells you what the problem is. But if I really wanted to do that, what I want to do is I want to do element by element. I want to take every individual x, and square every individual x. And the way you make it do it is before the operator, you just put a dot. And putting that dot right there just says, when you do this, I want you to do element by element math instead of matrix math. And so you put that little in. So and that's what it does. It squared my ones, squared my squared my 1.1, squared my 1.2, squared my 1.3, squared my 1.4, squared my 1.5. And that's really what we want it to do, is to square the individual elements. Right? That's it. That'll come up. That's a major, that mistake happens over and over and over and over and over. Right? And then what a lot of times your students in the past have done is they just put dots on everything. There's like, I just gonna put it everywhere. I'm gonna put it on a plus sign, I'm gonna put a minus sign, I'm gonna put it on a divide, I'm gonna put it everywhere. You don't have to, right? Matrix addition already does element by element. Matrix subtraction already does element. So you don't have to put it before those dots and stuff. So just be wary. I mean, when in doubt, maybe put it in there. When in doubt, put it in there. Okay. It looks like I got this talk thing. Let me show you this. If in case you ever want to if you ever want to see how long something takes to run, what you do is you put a tick. You just write tick above, and then down below you write talk, and then when you run it, it'll tell you how much time. Elapsed time is 0.0268 seconds. Right? So if you ever want to see how long a calculation takes, because we will do that later, we'll say, we're going to run these thousands of calculations. Can you tell me how long it took? That's what I want you to do. Put a tick above and then talk where you want it to come out, and then go from there. Just to show you, something here.
You put it at your bookend.
Yep, bookend what you want to. Yep. So I put it. I ran that code right there. Right, and then it ran. So it's squared. How big the size of X was 91 elements. So it squared 91 elements in 0.0046486 seconds. Then just to show you, we'll learn about this. 1e negative 6 would be 6 zeros before the 1. Let's see what I'll take. Right? I mean, isn't it crazy how fast computers are? Length or size. Okay, that is. Because is that not? There's 1,000. 90 million. 9 million. 9 million calculations in 0.023 seconds. 10. Oops. Oh, it ran out of memory. All right.
That's a lot of memory.
All right, that took a little longer, huh? That's. Nah. Is that 900 million? 900 million calculations in 3.5 seconds. What do yours do? Do this on your computer. Let's do a little battle. Let's do a little battle on my new MacBook Pro versus your.
You brought a new one today.
Yeah, I just got it. I brought it in on last week there.
You just got it.
Just got it.
This is just a for fun thing.
Yeah, for fun.
Like we would never be like we need to know this.
Well, no, sometimes. No, you never have to know the exact amount of time, but you will for some homework assignments and stuff. But I'm just curious, just for fun, right? Just use the same code. X goes from 1 to 1e negative 8 to 10 seconds, right? And then calculate
How do you
X squared.
How do you make it stop again? What's the button?
Oh, is it still running?
Yeah.
Give it a second.
It's not gonna. It's dead.
Oh, it is.
Like look at my ears.
It's busy. It says it's busy. See, it's busy. It's running. Down bottom left-hand corner, it'll tell you if it's running. Just it seems like nobody's fancy enough for me.
Oh, it says busy.
Oh. Oh, we did plots. We did plots. Yeah.
Mine is kind of crashing up today.
You guys crash it out. Don't do mine then. Don't do 1e negative 8. But do 1e and there's work. Looks like my computer wins, motherfuckers.
No, but still, how do you
Oh,
get
what
rid of
happened
it?
to your 0 button? What is this?
That's by like a significant amount.
Okay, right.
Dr. Barry, what's the stop? The
Control C. We did it. Well, how many seconds? Control C's not working. Oh, that ain't bad, Elliot. That ain't bad. You're still going? If it's stuck on the busy and it's not gonna do, Control C cancels out, and then it'll just break you out. Did it work, Bryce?
Yeah.
Yeah. And then try to go 1e7 then. 1e negative 7. See what it
Wait,
does.
if you, since we defined x and y above,
Yep, you just redefine it. So if you made a new x below, like I made a new x below, it just replaces the old x. It's a little loose.
so I tried to run it, but maybe because I got held up here, which I don't know why, but how do I try to get this? Can you just
Oh yeah, you should do cell by cell.
I like
This
kept
is
pressing
run
control
section.
until it stopped.
No, I know, right there, run section. One to the right. Yep.
So, as long as I
And then it'll only run this part.
because that one.
Yep, and then it says busy right there. So it is running. It is running. Well, mine said busy too, but only for 3.4 seconds.
Mine can't do -8.
Oh, you can do -7? How long did it take to do -7? 0.32 seconds, but it won't do 1e negative 8. Let me try 1e7. 57.2 seconds. Right? 0.4 seconds.
Mine's faster.
What? No, it's not. 0.11 seconds. 0.16 seconds. Look at that. Wait, thank God. Thank God. I'd have to go get a new computer if that's the case. But isn't that crazy though, right? Like your computers aren't that old, right? And this is a brand new one. Like the how quickly technology is going, right? With all the multi-cores and everything else, like just within minutes, or within like years or months even, you're behind, right? This is all probably already behind. This isn't the best one you can get. You get an even faster one. Did you get it? What did you got?
For the -8, it's like
30 seconds? Yeah. I'm so much better than you guys. I'm at least 10 times better than you. At least 10 times better than you. Yeah, try it on your desktop. Yeah.
that'll crush. I can't get the school to pay for my laptop.
Yeah, I know, right? I tell you, if it was my laptop, my last laptop I bought for myself was around 2001. I think was the last time I owned my own laptop. I used it for work. Actually, the one I used it was the biggest, fattest Dell you could ever see. It's just big old fat Dell. And it was a laptop, and that's what I got my dissertation with. And that, guess how much that laptop cost? This big, in those years dollars, in probably right around 2002, big fat Dell, top of the line fat Dell you could get. $10,000. 10 grand. It was paid for by the National Science Foundation, the top computer you could get. 10 grand. And it is, my phone is probably faster than that. Nuts. It is crazy. It is crazy. Okay.
I love microprocessors.
So cool. Okay. Illustrates. Yeah, this I'm just showing you what the element by element math is doing if you wanted to see. And then again, where you put the dots. I did some other examples here. Y2 is 3x to the second plus 2x plus 7, right? And again, you got to put the dot right here. I got to put that dot right there because it needs to know to do matrix math. But then you don't have to put it on the other ones because it's just doing regular. When you multiply a scalar times a vector, it automatically does element by element. Adding them already does it element by element. You could also do like in built-in functions in MATLAB. If I say what's the square root of x, and if x is a vector, it'll go through element by element and take the square root of every single element. And so I don't have to do it in a bunch of things. I just do it once, right? Same thing with cosine. If I do 10 times cosine of x, it'll take the cosine of every single element. It'll take the cosine of every single element. It'll take the cosine of every element. Okay.
Holy cow. It'll take the
Yeah, thank you. That's what I was looking for, Kayla. That was what I was looking for. Okay. All right. Let's look at plotting. And this last thing we'll do here. We're going. I said 15 minutes. Technically supposed to go 25 minutes, but we'll go 15 minutes. We got 11 minutes. Plots. Just cut it out. Unless you really want it or you want the extra time. I'll give you the
Bro, give us 20
last class of the week. Last class of the week. I mean, we can't go Friday. This Friday, we can't go back on our promise. No Fridays, right? You can't.
Are we not bringing treats anymore?
Your treats are
You
out.
can.
We can do treats on Wednesdays.
Yeah, Bryce, we can do treats and treats.
Yeah, Bryce, you can do treats on Wednesday.
Okay. I brought in 2 treats now. I brought in Pop-Tarts and caramels. So, all right. And you can see Pop-Tarts is a really low bar that you have to bring. No cooking was involved. They weren't even toasted. Okay, so yeah. Toaster strudels. Bring in those. Those are way better. Toaster strudels,
Yeah.
aren't they? Yeah, yeah.
Not even warmed.
We should go to 420. We should go 15 minutes.
What?
We should go to 420 instead of 4.
420. All right. So plotting. Okay. Here's what you find in the plotting command. Help would be really helpful for you when you start plotting. We're gonna have to separate you guys. If I have to put some of you over here.
They're just berated.
He's just
Elementary schools.
Yeah, I'm gonna have to assign seating from now on. Okay, so you're gonna want to look up the help plot and help at some point because there's a lot of stuff that goes into it. Plot x comma y, great. If x is a vector, y is a vector, and you plot it, it'll go. If x is a matrix and y is a matrix, it will also plot. It'll treat each row as if it's its own plot. So if you had a matrices of a bunch of them, they'll treat each one as a plot, right? And then it'll automatically put in different colors and stuff, or different colors and line types. You could specify the line type that you want. We'll look at some of those, and you could do all sorts of stuff with them, right? And then what can you do with them? And what are the line specifications? Everything. They're all over here. Right? Here's what you could do with all the different things. The different line specification. If I want to dash, or if I want a solid line that's normal, if I put a dash in these little guys right here, it'll make a dashed line. If I put a colon in between the little dashes, it puts a dotted line. If I put a dash dot, it puts a dash dotted line, right? And then if you want to put an O at every single data point, you put a little tick mark and then an O in the middle. And there's a whole bunch of examples of how this stuff works, right? And then you can change the colors. Here are the different colors and how you do it. These are the RGB colors over on the side here, right? So let's see, plotting, right? So one thing I usually do is I call out the figure first. You don't have to call out the figure. You don't have to call it out. I usually do it just because sometimes you want to plot different things of different figures. And so I usually do figure 1, and then I plot x comma y1, and then you could do another plot afterwards, like x comma y2. And then if you want to create a new figure, you do it like that. So let's do this. Let me see if I got a. Okay, so we'll work on that example in a second. Okay. Let's do this. I'll write this one out. I'll demonstrate a plot. You can follow along too if you want. Okay. Plotting. Okay, I've already defined. I'm gonna shorten the 1e negative 7. Right? It does those calculations. If you ever asked to display x, which is 90 million characters long, it would take so long because it would sit there and try showing it, and then it would just start scrolling down super fast. Don't ever do that because it'll be a mess. It would be a mess, right? So I'm gonna go back to 1e3 negative 3. So that's 0.003, and then I'm gonna do that. Okay, and down here I'm gonna say plot x comma y1, right? And if I do that, it'll just automatically make your figure. It won't necessarily. Right, and in the .mlx file, it'll just put it right there. It'll put it in the same file, and it'll either be on the right or left. Right, there it is over on the right. Right, and there it is. Right, there's a plot. Plot x comma y, and there that sucker is. Okay. Again, if I want to change it, if I want to change something about it, say I want a dash line. So what you do is you go x comma y1, and then you put another comma. Just say, now I'm going to give it a line specification. And then you could do all sorts of stuff. I'm going to put that little dot, I'm going to put little string character there, little single quote. And then I'm going to say, I want it to be a double dashed line, and I want it to be red. And so I just do double dashes in a red, and this thing should come out with double dashes and make it red. All right? Pretty clever. Okay? But then also, if I wanted double dashes in a red, and then I wanted every point marked with an O, and I put an O there too. Obviously that doesn't work out that great because there's so many O's that they overlap. They overlap. Thank you.
What?
They overlap. The O's overlap. Get it? Okay. So there it is. There's the plot. right? And again, if x and y both have to be vectors, because MATLAB only knows how to plot vectors, right? And so they both have to be vectors, and then and that would be, this is plotting x versus x squared, basically, is what this is doing. Okay, if I made another one, let me make another variable, y2 is equal to negative y1, just to define another variable. So now I just have the opposite, and I could do, and now if I do this, if I do plot x comma y2, I'm going to make this magenta and double dot. Okay. And what happens, well, it's interesting, they put it on two different plots. Okay. So but what usually what happens is it just replaces the old one, right? And you can't, you don't ever see the first one.
Don't you have to hold?
Yeah, so that's my point. So that's what I was just going to get to. If I want them both to be on the same graph, I have to put this. I have to put a little thing called hold. I have to say hold on. Okay, and when you put the hold on, it just says, right, I want to put two things on this plot. I don't know why it does it that way, but it's just by default hold is off. And so if you try to plot it, it'll just put them on two different figures. It looks like .mlx and put it. If you do it as a .m, it'll just replace the old plot. You don't even get to see the old plot. And so just be careful of that. If you want two things on the same plot, you have to put a hold on in there, right? Just say, wait a second, right?
How do you get that plot off out of MATLAB?
So you can, good question. You could, if you click on it, you get this little, boop, pops it out.
Cute.
It is cute. Later on, it's a pain in the ass. And then there's actually a command you can have in a .mlx file that kicks it out. We'll learn about it later. But like one of the commands that you could write, you plot this, plot that, and then you hit this little button that says pop it out, and then it'll kick it out and make it its own. Because sometimes you want to use it on its own, right? Because once it's out here, you could do all sorts of stuff to it. You can zoom in on it, right? You can zoom in on the plot. I can wave at it, right? You could ask for certain numbers and stuff like that. I think you could go down and pick certain components of it. I don't know. Can I paint on it? Paint on it?
So
Oh.
does for the hold on command, does that have to be in the same line as the
Nope.
first
No,
one?
no. I just put it there.
Imagine
Yep.
that.
Great question. Right? I put it right afterwards. I put a semicolon and afterwards. You could put a bunch of stuff on the same line. Like I could even put this on the same line. I can put it up here if I want. As long as there's a semicolon afterwards, you can line everything up if you want.
I'm gonna submit one line.
Everything
As an
just
assignment.
one long ass line as you go along.
And then on for this here where you have like the M semicolon.
Yeah.
Sorry if I missed this. Does it matter if this
Nope.
the order's the M?
Nope, doesn't matter. Yep. As long as it's just looking for those things. You can also, there's all sorts of stuff. Like you could go,
Change thickness and stuff too.
yep, line width, I think. Yep. And then and see how it kind of like starts filling in. Line width, 1.2, right? 1 point, what would we call it? 2. Right? So it made that 2 is thicker, so you could change the thickness of it. Again, you can have the O. What I was saying before about the O's, let me just get down so you could see it more. Right, well, not even too many there.
What is line?
Yeah, I tried to show the O's. There you can see the O's I'm talking about. Every data point gets an O. Right. But again, if there's too many data points, it gets weird. So then once you make your plot, then and again, this is all in that little handout thing. You could do this, right? If I want to give it an X label, right? Call it X, right? And then Y, X, Y label, X, X to the second. Again, they have to be. Right, so then that puts an X label and Y label, and then they have to be strings when they go in there. right? That's what I mean. Like, you can't just put X. If I put X, then X is all those numbers. And it's trying to use all those numbers there. But I don't want X as numbers. I just want the value X. And that's why you put those little quotes on there. Just say, I just want the letter X. And then I have just the letter X squared. Right? And look, it even makes it pretty because it puts it in a superscript like that. You could even, if you really want to, it even has like Greek variables like alpha. Right? Yeah, see, like it did an alpha there. See that? Just a variable, like if you wanted to do it, like it knows Greek letters. Like if you use this right here, I just said I'm gonna label as an alpha, and then so up here on the graph, it turns out as a Greek letter.
How do you make it a capital Greek letter?
Capitalize it. I made that up. Let's see if it does in fact.
Oh, it doesn't know.
It doesn't know.
That's ChatGPT.
What's a capital alpha look like?
I don't know.
It's just an A.
I thought. Yeah, look at that. It does. No, it just doesn't like capital alpha. It says that the capital alpha's stupid, but it knows capital
It's like
gamma.
Capital A, so
Yeah.
it's not special.
Yeah, but capital gamma.
It does know.
Yeah, if it's just a capital A, then it just does it. Already knows. Just make it an A. But it knows capital gamma, right? I like this one. I use this on the graphs, grid on. Right, it makes you grid like that. Yeah, grid's nice, right? And you can change. You can do anything you want with these plots, anything you want, right? And then where you determine what you do with those plots, right, is under the plot help, right, or the right plot help will do all that. Oh yeah, all the different colors and what the codes are for the colors and what the line specification. There's a whole section on.
Are we limited to just those colors?
Nope. It also takes the RGB triplets. How much red, how many green, how many blues, and then you could put in. So it's like 1, 0, 0. You could put in 0.1, 0.1, and 0.7 or something like that. So you can make all sorts of stuff. If you really wanted to, you can make up your own colors. Your own colors, your combination of RGB.
255.
Huh? What?
Isn't it usually like 255, 255, 255?
No idea.
That's a
RGB stuff?
white.
Yeah. It's usually like 255.
0, 255.
And then there's all like I said, all sorts of different things on line specification. You just look in the help for all that, right? So figure plot those ones, hold on, creates a new figure, plot. Oh, you could also do multiple things in the same plot like this. X, Y1, X, Y2, X, Y3, X, Y4, and then it'll plot all of those in the same plot.
So with that legend, can you also tell it where to put the legend?
Yep.
Okay. Is that the default for the legend?
Default's upper right, but then you can tell it, like when you make the legend, one of the commands, just like this other one where you put the command and then comma, and you could say, I think one of them is position. So under legend, you say position, and I think that's northeast. You say northeast, northwest.
Can you put it outside of the plot?
Don't know, probably. You could do anything you
No.
want. You could do anything you want. We're gonna learn it later on, like there's a, right when you get to a point where like you're doing these plots and it's the same type of plot over and over, and you're writing a paper and you're using the same plots over and over. You're writing a dissertation, it's the same thing. You set up, like I made a function that said make like once it plots, I say format figure. And then it goes through, and there's a function, and it goes through, and it labels the X, it labels the Y, it turns the grid on, it sets the line types, and then it puts the legend where you want it, and then even in that function you can make a PDF of it, export it to a file, save it in a certain spot, and you can tell where it goes. You can see the power. You can custom function. We're going to learn how to make custom functions, and so you can imagine you're doing all this coding, and you're like, well, that's what I. In my dissertation, I made this like the same plot over and over for all these different scenarios, and I would say, all right, at the end of doing this, I had a little for loop that looped through it, and I said, at the end, do this stuff, and it would format it, and it would export it, and it would turn it into a .eps file, and it would store it in a folder. And then I made a MATLAB code that went through and generated LaTeX code, because that's why I wrote my dissertation in LaTeX code, that said, read in all of these figures that I just created, and then I put it into LaTeX, and then it ran, and then it just went and grabbed all the figures that I had, and then brought them in and put them in there. It's so fun. It's fun. especially when you're.
So you were supposed to code in LaTeX, and you decided I'm actually just gonna code in MATLAB and make MATLAB code to write LaTeX for me because
Yes.
I want to learn LaTeX.
Well, I know LaTeX because I had to.
You just like MATLAB better.
No, it's just MATLAB is a programming language that has for loops and stuff like that. LaTeX is just a word processing like language without for loops and while loops and stuff like that. Yes, Joseph.
Just got a quick question. What does this mean right here? Render process terminated, null, Java lang, no such field error, TS process.
You did something wrong.
It deleted all of my code as well. So,
Why do you have your command window over on the left?
I don't know what ooh is.
What I would probably do is shut it down and bring it back up. It should still be there. If you were running it and saving it, it should all still be there. Okay, cool. 420. 420.
Oh, perfect.
Thank you.
420. All right.
You got your money's worth.
And so I'll give you got your money's worth. And so we'll do this exercise next time, and then in the meantime, assign a homework, so you could dive in and start playing.
We'll be due for our
I
next
feel like an
class.
hour.
I think it'll be due next. Oh, I was gonna say it's Friday. It's probably next Wednesday. Yeah, due next Wednesday.
Do it now.
Yep. No. Next Wednesday. Yeah. Well, it's next Friday, but
I'm literally calling HR. I'm brown. You can't do that.
Turn it in whenever you want. I don't care.